All right. So let's talk about problem like number 2 first. Get there. Okay. Okay. All right. There we go. I got paper. Yeah. So number 2 gives us this information. It's specific. I don't give you what the transformation actually is, which seems like it would be good to know, especially considering my first question. Apply the transform you don't know to this vector. So understandably, you might have said to yourself, what? I don't know what the transform is. But I do give you enough information to kind of piece it together. It's a linear transformation, which is a ton of information given to you in 2 words. If I subtract the inputs, what happens to the outputs? So for example, if I do t of b minus a, let me write this down. If I know it's linear, Jeff, let's start with addition. If I know it's linear, here. Become like I want you to be. Okay. What's t of a plus b? Yeah, okay. So what is t of a minus b? Holy shit. So if I know t of a is c and t of b is d, what is t of a plus b? Holy shit. Okay. So therefore, if I'm given information about these 2 inputs, and I'm asked a third input, if that third input is related to the 2 I was given, and in this case, it has to be, because the 2 inputs I gave you are linearly independent from r squared. They span all of it. So I don't give a shit what I asked you next. You can always find how they relate to each other. You guys kind of with me? So for example, if I would have given you t of a and t of b, and I said, what's t of 1/2 a minus 3b? What would that be? Yeah, because again, linearity. The transforms of scalars, scalar multiples of inputs become scalar multiples of outputs, yes? It's a long way to say t of cb equals c t of b. Okay, maybe. Maybe think about t of e, which is from a whole different thing. Fear of lost disenchantment. Okay. So let's look at the actual problem I was given. That would be really good, Jeff. I was given this information. T applied to 1, 0 takes that to -4, 3. And t applied to 1, 1 takes that to -10, 8. And then I said, what is t of 0, 1, I believe? Yes. So all you have to do is figure out how are the inputs that I know related to the input that I wanted. Because then I can do the exact same shit to the outputs, right? You guys see what I'm saying? What do I do to the inputs to get the input I want?
You subtract t1, 1 or t1, 0.
Since it's linear, I can go straight to this. Because 0, 1 is equal to 1, 1 minus 1, 0. If that's inside a t, it can come back out like a linear. I can do t of each piece. Are you guys at all with me? Is that okay? I'm applying what I did tell you about very directly. So I know at least one of you guys pieced together how to do this problem. It's based off of exactly what I told you. So what do you get then?
10 plus 4, which is
Yeah, let's do this. Let's be very specific here. I'll be at negative 10, 8, minus negative 4, 3. So I'll get negative 6, 5. Kick ass. Kick ass. Now, sorry. I'm going to ask you this question out of nowhere. What matrix do you think? All right, let me just ask. I know what t does to 1, 0, and I know what t does to 0, 1, which seems very useful information. So what matrix could I set up that would actually accomplish what t does?
Negative 4, 3.
Yeah. So if I'm trying to figure out, how did I write it? Yeah, t of u equals a of u. A would be just negative 4, 3, negative 6, 5, because I actually got what it does to the basis vectors, yeah? There are ways around that. If you don't have it, that's the easiest way to set that up. And you can check it out. I mean, if you apply that to 1, 0, you'll get negative 4 and 3. I mean, you can see it directly. You guys kind of with me? And you see, if you get what it does to 1, 0 and 0, 1, that's what leads to the matrix being so easy to set up, because 1, 0 is like a laser. It just ignores the second column. It just picks off the first column. Does that make sense? If I dot product, I just get the first column, right? Are you guys all right? All right. I can't talk. I feel the same way. I would be sitting there with a glazed over look on my face if I didn't have to be up here. Okay. And then part C is pretty easy, yes? Why is part C so much easier than A was? Because now I know how the hell it works. Yeah. I like it. Part D, I don't know. I'm curious what you guys did here, because this, to be honest, part D, I don't want you to apply the transformation. But you can use information that we know. And I know what t does to 1, 0. I know what t does to 0, 1. So therefore, I have to know what t does to 5, negative 5. I don't know. Do you guys see what I mean? Because what is 5, negative 5? It's 5, 0, plus 0, negative 5, or even minus 0, 5, right? And then you just have to take multiples of those. Is that okay? Go ahead and try to do part D. Hopefully you've been following along. If you haven't, then just sit there. And I'll catch up with passing this stuff back here. Let's see. Anybody in here that didn't get their test? Oh, yeah. That didn't get their test back? Anybody didn't get your test back? Okay. See, Jaden's not here. Alex is not here. He had enough leave in the earlier class. Gene won't be here. Ivan is not here. Anthony. Beth. Christian's not here. V finally decided to show up. Ricardo's here. But that is not. Oh, I'm not totally up here. Some of it was right, most of it was not. Deleted it. You're welcome. Mr. Khan, I think he's not here now. Okay. All right, so how's that going? I need you to see, because this is linear, even if I just gave you this shit and I said it's linear, you can immediately write this. That's the scalar multiple application, and that's the operator, the transformation of the sum or difference is the sum or difference of the transformations. Is that okay? And then you just put those together, because you know what those are. So that is one kind of problem I could give you related to transforms. This one should be even better, yes? Number 3. Did somebody try on number 3 yet?
3? Yeah.
What'd you get?
That they're not linear.
No good. Yeah. Either one actually will lead to a problem.
Yeah, because
So I would just do the scalar multiple one, to be honest. It's a little quicker.
over the plus.
Over the sum of two different things, yeah.
Yeah.
It's just more direct.
Well, I just, for the plus part, the u plus v, I just looked at it, so seeing that x times y. That's how I was like.
Oh, yeah, yes.
that's
You
how
could
I-
look at it and explain why it would, as long as your explanation is good enough, you can explain why it would run into a problem without actually running into the problem, yeah.
Yeah.
And then let's look at number 6. That's the other kind.
Yeah.
This one's got more information. Okay. So the first part of number 6 is, well, actually, let me see. What do you guys think?
Express it as t a t b.
Yeah. Can you guys, if you haven't tried 6A out and you want to play along, go ahead and try it out. If you have something better to do, do that. But if you haven't tried 6A out yet, try 6A.
Is range the same as range?
Say again?
Is the range the same as like range almost for t's?
Here's the beautiful thing. You ready? So remember when we had ax equals b and we said what b's work? Is that what you're saying?
No, I'm saying is like the for like part B. Where it's
No, I know. But when we had ax equals b,
um,
what b's would work? Where would they have to be?
they have to go in the column space of A.
It isn't b like the range of a, because if you look at it like a function, the input's x, the range, the output's b.
So yeah,
Yeah.
so
So the range is just the column space.
Okay.
Yeah.
Gotcha.
Bum 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 bum. Bum bum. All right, I'm not sure if you guys see what to do. I mean, there's several different ways. One kind of very direct, sure, Jeff. One direct way to do this. It's just to write down the transformation for ABC and then start to tear it apart. This kind of feels like what we did with finding the null space and stuff like that. Yes? I should have asked you what you guys were doing, but look at me, I'm just doing this. So you guys see that? So what do you think the matrix is that?
Just that.
Because we can directly see this matrix has been applied to this vector. I mean, when I do a times a vector, the vector are the coefficients of the column vectors. That's the column picture of that multiplication. So that's why just doing this, you can see what matrix captures the idea of that transformation. Okay. So that would just be 1, 0, 2, 1, 2, 0, 0, negative 1, 1. Now, Zach and I were just having a conversation about the range. If I say f of x equals y, what part of that is related to the range? Y, I love it. So if I say ax equals b, what part of that's related to the range? B. So when we did ax equals b, when will it have a solution b? What must be true about b? No. What must be true about b? I don't need full rank. I can have solutions to things that aren't full rank. It must be in the column space of A. So the range of a transformation is the column space of its associated matrix. Some of you guys didn't like that, I'm sorry. I didn't think it would be that terrible. There's no better way to say that I can think of. So how do I find this guy's column space? Row reduce. Yeah. So if you row reduce this, or to be really honest, well, I mean, you have to have some way of seeing that it's. Can you guys see how the third column is dependent on the other two? Yeah, it's because you have a 2 and a 2 and a 1, 1, so I mean they'll combine and make that if you get the right coefficients. So, and you know that the second column vector is not a multiple of the first, so the first two column vectors are, yes, so then that could be your column space. Does it make, if you think about it, the range of this transformation, it's exactly like me saying what's the range of this function. Since the transformation can be captured by a matrix, the range of the transformation is equal to the column space of the matrix. Because what is the column space? It's everything that matrix can create. So of course that's the range, because what it creates is the output, yes?
So range equals the range.
Oh, you mean the dimension of the range?
Yeah.
Dimension of the range equals the rank, yes. The range equals the column space, yeah. And of course, the dimension of the column space is also known as the rank. So you're right. Okay. Dimension-wise. Okay. How you guys feeling? Are you guys feeling all right? I mean, I to be honest, compared to some stuff we've done, this is unbelievably straightforward. Yeah. I don't know if you guys agree with me. So in much the same way that we have kind of like function, oh my poor finger, we have like function speak and matrix speak mixed together here because I have a transformation that is inherently functional that's represented by matrix. So kernel is just what we call all the inputs that lead to 0 outputs. Kernel is not a word that only applies to matrices. So another name for kernel, when I'm working directly with matrices, which is what we're going to do with these transformations, another name for it is just the null space. The null space of the associated matrix. So I want this to really make sense. Range of T is equal to the column space of A. Kernel of T is equal to the null space of A. So not special about kernel. You can think of it just as another name for null space because every freaking matrix we've ever looked at in our entire lives has been a transformation.
So would also, since it's in that like A plus B to B minus C to A plus C, couldn't you just set all those to 0 in the kernel?
I mean, effectively, that's what you're doing. But since you've already row reduced to get the column space, you can use that row reduced form to get the null space.
Okay.
Right?
Yeah.
But, I mean, you're right, but we've already done a lot of that work.
Yeah.
Yeah. You guys with me? And if you can't find a null space for that matrix we got up there, that's a problem. You would have row reduced that matrix, yes, to answer the part B. So then you can use that row reduced form to get the null space. That's just what C is. Now, in terms of the dimensions adding up correctly, what do you think the dimension of the kernel, where'd it go? There it is. What's the dimension of the kernel of T plus the dimension of the range of T? In this case, it's got to be 3. Yeah. So it's again, this is just column space and null space. So the dimensions of those still have to hold. They still have to follow the same rules they had before. I'm just using the new terminology for transformations. So those are the kind of questions I would ask you. Okay. If nobody asks anything, I'm going to assume that went fantastically, and everybody gets it totally. I kind of stole this from an earlier test, I think, or something. Yeah. But I think I added. Did I add anything? No, I didn't.
You only changed it from.
I think I changed some of the notation, but that's about it.
I think you may just have to do it in rank 1.
I did more with it. Yes. Okay. Ha ha ha. Sorry. But it is kind of interesting. Anyway, there is something interesting that comes out of this work because no matter what you guys did, and I don't know, not a lot of you did this, did you? It's okay if you didn't. It's fine. You got a lot of shit going on. I didn't mean to sound like I was being accusatory. Not a lot of you guys do. I made it. I took a lot of work. No, it's great. No matter what you pick, what do you think that your row space is going to be? What's the dimension your row space is going to be?
It's gonna be.
It's got to be 2. Yeah. So both of these have to end up being independent. So if you just think about it for half a minute, you'll see why that's got to be true. It's another one. It's an interesting thing that we didn't get too deep into. Believe it or not, there's a lot we didn't get too deep into, but just the connection between. I mean, we know from the beginning almost that the rank of the column space and the rank of the row space are the same. But we didn't really get into how they truly affect each other. There are a few problems that kind of hinted at it, but not really. But it's okay. We'll be fine. And I really enjoy this last problem. I think I told you guys I wish I would have made this the final. I should have made this the final and just made it different practice, but now we got to make a whole other. Was it this one? Yeah, look at me doing all kinds of weird shit. So this is one I stole from the first test, and then I added stuff from the more recent history. It's neat though. It's really, you should be able to predict what F will be, what angle you'll get in F, if you really understand what the Gram-Schmidt does. And if you can't predict it, it's fine. We'll do it and you'll see it and you go, oh, okay. But there is a nice connection between the answer you get to part, what was it?
Part
Find Q2. Oh yeah, find the angle between Q2 and A2. I thought it made you find the angle.
A1, A2.
Oh, that's right. It will connect. That's right. What you get for part F will connect to part D.
What, that they were close together?
Well, you'll see. I don't know. Did you do it?
Yeah.
Which?
My
What do they add to be your angles?
Oh.
Oh. Okay. Yes.
I know you already went over, not question 2, sorry, question 3, but can you explain it a bit more, please? Question 3.
Oh yeah, of course. I didn't really talk about it that much. So, what 2 things? This kind of feels like checking to see if something's a vector space, right? There's certain things that has to follow. There's certain things that this has to follow to be linear. There's 2 things specifically. What are those 2 things? T of u plus v must equal T of u plus T of v, and T of cu must be CTU. You might be able to see how this kind of stuff is right for really dumb jokes. But, CU, if you apply either one of these, and I would apply the scalar multiple one, to be honest, because I'll give you this hint, 3 breaks both, if I remember correctly, but if you just, so what you do, what kind of sucks, a little bit, if you want to try the first one, don't I already have, if I call this vector here u, I've already got that. So now I just need to figure out another one, maybe a, b, I can call this vector b, yes?
Yeah.
So I write what that is, and then I add them together, and then I compare to what I would get if I add them together and then plug them in, yes? You guys follow? So I plug in xy, I plug in ab, I add the 2 outputs. I plug in x plus a, y plus b, and then I get something, and then I see if they're the same. If they're not the same, it's not linear, you can stop. You don't have to check the other one, it's dead in the water, right?
Yeah.
Poor little dude. That one dies. Just watch it. It does stuff, it's great. It's a good transformation, it's just not linear. There's a lot of cool shit we didn't get to, man. There's transformations involving derivatives, transformations involving integrals that lead to pseudo-inverses, transformations. Oh yeah, it's just silly. But it's okay. So, guys, today's review, so I mean, it could be anything you want to talk about. You have something from section 2 homework that has given you nightmares ever since you tried it. If you got something from the practice final, whatever.
For the homework and like test corrections, is it due next Wednesday or the Monday?
Oh yeah, okay. I keep forgetting to say this. Monday, final exam part 2 is the day that everything is officially due. Yes? I keep saying the homework corrections are due the day of the final, and some of you guys are like, there are 2 days of final, John. So I'm gonna officially make it the day of the final part of the final. The most final you can be. Yes?
And it's all up to 6-2 and then
6-2 and then 8-1, 8-2.
8-1, 8-2.
Yes.
Okay.
Everything in between is extra credit. And you should be able to do, like, if you try to do chapter 7, you should be able to do it. It kind of introduces more notation, but it's the most important section you get to is chapter 8. Even though it wasn't really heavy, which actually in its own right was a great way to end the semester with something that wasn't terribly heavy, it was just really important to get out there because it's the way we look at almost everything. It's a transformation. In relativistic electromagnetics, you have a matrix that you apply to something to see how mass changes as you approach the speed of light, how length changes as you approach the speed of light, whatever. So in a lot of different fields, you have these matrices. And why do we use matrices? Because they're a way to hold a lot of information in a relatively short space, very concise. And the operations are really well defined. So it just makes sense. It's a beautiful way to contain a lot of information. So I look at matrices as little subroutines that we can write that just, we can create them and then they can do what we want them to do. Yes? See a little happy face there, sticking his tongue out. Yes, I'm sorry.
We can decide what section we will have for part 1 and part 2.
Oh, okay. I'm going to ixnay the idea of early stuff, late stuff, because I want to be able to mix ideas, sort of like I did in the practice file. Yes? Does anyone, besides, one way I could do this is I could make a final that would take about 2 hours and whatever, and then just cut that in half.
Yeah.
Without any idea about what's where. Or, if somebody has a suggestion as to, I don't even know how to break it up, considering I want to be able to mix stuff. One way I was trying to think about it, which doesn't really make sense, would be one day you can't use a calculator at all, and the next day you can, but that's dumb. You should be able to use a calculator whenever you want to check what you're doing, so that's dumb. I really don't know how to break it up, to be honest. Yeah?
Just like
That's what I'm thinking.
1 through 4, 5 through 8.
No, I just said no.
No?
Because I want to be able, like I did on the practice file, take a problem we've done earlier and then give it a later twist. That's exactly up my alley.
What about odd and even?
What do you mean odd
Odd
and
and
even?
even chapter.
Oh. No. I'll do Fibonacci numbers of assignments. Yes.
Oh, Jeff, you said we can decide what we can have with us when we do our tests. You remember?
When did I say that?
Last time. Last meeting.
That's funny. Am I really? That's funny. I'm waiting for that day when people are like, this guy doesn't remember shit. Let's just tell him. Hey. Really? Am I there already?
So
Yes.
we're only gonna be able to import that day, we can't go back to.
No, exactly. That would not make sense. Because then you just go study what you did and say, can I get that first part back? No. Of course not. So we really, I don't know, that shouldn't change anything you do. Right? Do it again?
What checklist would we put in the exam?
Everything that we've done? Yes. Yes.
Can you just do an A with QR thing?
Sure. Okay. Oh, that's right. Is that one of the ones we talked about that I said I might put on here?
that must be the R's like the Q1, T, A1.
I'll tell you this. I'm not going to put that on there. Yeah. It's fine. We've done enough for that. A equals QR is very important, but I mean, it's just, I am gonna make you do Gram-Schmidt, I'm gonna make you do stuff with orthonormal stuff. That's just kind of like one extra step on top of that, and it's just, it gets messy. It's obviously very important, but you have the parts that are necessary for it that you're gonna be tested on anyway. Yeah.
Will there be bonus questions on both, or just one?
I'll probably put bonus on both. Bonus on both, yes. Bonus on both. I will say this, if you have a desire for certain ideas to show up on one day or the other, I could take those suggestions. But I mean, yeah.
Can we put the eigenvectors to one there?
So you want the eigenvectors later. See, if I was a student, I want the more recent stuff first. But, let's say again,
I want them the other way around.
like I just said?
Yeah.
Okay, so I'll surprise you. Sorry. Like if everybody in here, for example, wanted, I don't know, Gram-Schmidt's not good because I want to mix that with something else. But I could give you that problem one day or the other. So if everybody in here was like, we definitely want Gram-Schmidt on Monday, then I would do that. It would be a problem that probably has other shit, and then you do Gram-Schmidt, but I would put it there, yeah? Oh, I'm a poet and didn't realize. Scott shit in Gram-Schmidt. Yes,
How many versions will you make for the finals?
huh?
How many versions will you make on the finals?
At least 2. Yeah, which is great for me for grading. But it's not like it's not that I don't trust you, but I don't trust you. No, I can't trust every person. Let's just say that. Yes.
You want the secret practices?
I do. I can give it to you right now. I'll go ahead and give it to you right now. If you want. Where'd I put them? Oh, there they are. Huh?
Wait for the answers to the practices.
That's what I'm giving it right now. It's a perfect timed question. Make sure you have both parts. You should have one page that's got 2 sides to it and one page that's got 1 side to it. Exactly. Yes. You either left me blank or something went wrong. That's kind of like, it's assumed that.
My mind is moving suddenly.
Nice. Come on, I got stuff for you. Let me put this. I guess so. Hold on. No. Let's see. There. So just make sure everybody understands. Oh, yeah, you guys need it. Everybody understands the homework you got back. Anything that doesn't have anything written on it is assumed good. It could be very bad, but it's assumed good.
Does that mean you're still collecting homework?
Hell, whatever homework you haven't turned in yet, I haven't recorded that you've done it, so you probably want me to do that. Only way I can do that is if you give it to me.
You assume for that too?
No, until I see it. See, at least for this stuff, I had physical evidence that you had done it, so. Just assume I got all the corrections right. Just assume I got the whole final right. Yes.
So can we clarify what we can bring to the final? Like, there was that one formula sheet. that
You
we
can
talked
bring
about.
that same sheet, although by this point, I'm almost certain some of you guys have that process that you had, the sheet that's got the Graham Schmidt process on it. Alright, let me open this up now, let's see, I'm gonna make this a little democratic. Do you think there's anything else, any other processes you should be able to have information about?
Laptop working internet.
Do it again? Laptop with what?
I like that.
So you want information about a laptop with working internet? Okay, I'll give you, now I gotta remember to do that. I'm gonna do that just for you. I'm gonna give you a guide. So you got a laptop and you wanna get on the internet. I'll do that.
Can we have the B equals C inverse AC process?
Oh, for diagonalization?
Yes, please.
Okay, let me think. What do I think about that? Is that on that sheet I gave you? Is that what that was about? No, that was, yeah, that was, didn't I give you chapter 6 notes?
Yes.
Okay, so that's on there, right?
Yes.
But there's also too much else on there that I don't want you to have access to, okay? I don't know.
You just kinda-
Yeah, I know. Would other people like that? You know what she's saying?
You can remake a sheet for.
No, I know. I could just put it right on the file. Okay. I don't know where to keep a note here. Let's see. If I put it on here, I'm not gonna look at this again. Somehow we gotta remember to do that.
Are you able to also put in the textbook's notation, because it's a bit different?
Oh yeah, with the weird
Yeah.
A without the bar in the middle. Yeah. You want it in the textbook notation?
I'm saying both.
Same both. Okay. Sure. Do me a favor, Annie, since you're asking so much. Send me an email and remind me. I really want you to try to say, I said we could use all of our notes. No.
Well, you could put processes for the ones you want us to have the exact process.
That's what I'm saying. I just have to remember to do that.
But then for the ones you don't want us to have the process, you could do something like as vague as you want it to be.
Or I just don't say anything and just ask you a question. Yeah, that's what I'm gonna do. Yes, I just gotta remember to put the ones on there. Yeah. At least once, for sure, yeah. And so I'm not gonna give you a 7 by 7 with no 0 in, that would just be stupid. If I do, you can full on freaking, what's his name, Will Smith and what's his name is,
Chris Rock.
yes, thank you.
Give us a 20
Give it to me, and I'll be up here going, okay.
Give us a 20 by 20 and then bonuses.
The bonus, I can do whatever the hell I want to, so don't even give me your ideas. No, a bonus question I would give is a 20 by 20, where if you realize something, it's barely any work. The best bonuses in the world are the ones that take very little time. If you realize something. Yes?
Will we have A equals LU problems?
Yes, could be. And that's a process you've had to know, so, yeah. So these different factorizations are very important, even though more recently I've hinted at bases related to eigenspaces are very often the best if you have them available. That doesn't mean that they are the best in every situation, yes? So these other ways to factorize something, you can diagonalize, that's based on eigenvalues, and that leads to easy ways to raise a matrix to power. A equals LU leads to an easy way to program a computer to solve systems of equations. But you have all other ways to do that, yes? It's just, to me, I always think the more tools you have in your toolbox, the more you can handle whatever situation comes up.
So you're gonna tell us what process we should use?
Like Graham Schmidt, I have to say, Graham Schmidt this thing. Now, I could say orthonormalize these vectors, and if I said that, would everybody understand what I meant? Hopefully, yeah. So I guess I have to tell you something.
Or like,
I mean, I'm going to use language like find the projection, and then you have to do the projection process.
find, or like, there's this kind of like, find you, find L.
Find what? Sorry.
Like, you would know to get, like, based by what you're asking.
Yes.
Right?
Is the hope.
Yeah.
Now, obviously, every test I've ever given you hopefully understand. If you don't understand something I'm asking, you just come to and ask me. I'm the only person that could answer that question for you during the test. And you never know how much I'm going to tell you. And very often I just say, what do you think? And you write it down like that's exactly right. You just don't have the confidence in that moment to realize that what you're thinking is correct. So if you write something down that's right, I'm going to say, yeah. If I write down something that's wrong, I'm like, that way. I'm not going to tell you what the answer is, but I'm at least going to give you some fact check. I always love these review days where people just there. I'm like, I didn't bring it. You guys know this. I brought the answer key, and I brought myself. That's about it. So what the A equals LU is not on here, but it could certainly be on the front. I'm trying to think if there's anything else major that's not on here. No, don't worry about Kramer's rule. No. Kramer's rule is just, I mean, come on. If you're really being honest, is Kramer's rule hard? No. But it's also uninteresting. It's also, well, it is interesting that it works, and then you get over that. And you're like, okay, what can you do? So there's not much you can play around with it. You know what I mean? I can't really put a spin on it. Not easily. Now that I think about it, maybe I'll make a roll.
Best fit line. Best fit line.
Sure. Projection, best fit lines, that could be on there. Oh, did I forget to put that on here? Damn it. Yeah. Yeah, projections, which are, and best fit lines are just a form of projection, or you can say it the other way. So that kind of problem could be in there.
Do you think you could pull out a textbook and just like read the chapter names and then like maybe that'll help you remember which ones you feel like you last chance to?
I don't understand. What's up? Sorry?
If you pull out a book with
Sure.
the chapter, then you'll be able to recall what you're forgetting.
No. So, okay. So here's the idea. Practice final is here. Does this cover everything that could possibly be on the final? That would be impossible. Not impossible, but it would have given you volume 1, volume 2, volume 3 of the practice final to possibly cover every single concept I could give you. If you did well with the practice final, you should do well on the final. Are there some ideas that aren't on here? Yes, I've already identified a few of them, yes. But no, I don't think that's going to really help. Especially if I don't wear my glasses. But if you guys have a specific thing you're worried about, we can talk about that. Yes.
The CDC thing.
Do it again.
The CDC thing.
Oh, yes, somebody asked about that. So I was going to include that on like a little blurb about that or something. Is that what I said? See, now you can take advantage.
Like how to factor it into that.
I'll give some kind of a keep in the right direction on the file. Yeah. Is that the one you're going to remind me about? Just that one.
The equals. that's
Yeah,
not like,
yeah.
but also in the textbook notation.
Oh yeah, yes, okay. Just in case you're more used to the textbook, yeah. So this textbook I think uses X. I think this is capital lambda, but to be honest, I can't remember what that Greek letter is.
It is capital.
It is capital lambda, thank you. So X, capital lambda, X inverse instead of C, D, C inverse. C, D, C inverse is far superior, although you can understand why they use capital lambda. That's like the parent with all the little lambda kids, yes? Lambda 1, lambda 2, stop that. It's very creative parents. What's my none to 3?
Which one was the line of best fit? I can't remember that one. Was it like a test or quiz we had?
Yes, in fact, that's not here, but it's tangent. You're gonna like this. It's tangential to this. Yes. So if you're given this, do you guys remember how the line of best fit works? What do you set up?
ATA.
Yeah, you set up the normal equation. Calculate what this is. Calculate what this is. Figure out the inverse, and then apply it. Right. Now you gotta be careful. Nobody really asked me about this, but the interpretation of the problem was not that it was the slope and intercept or the pieces of because they weren't. This is a very small detail, but I gave you the problem was solving a system of equations. So I wasn't fitting data, I was solving equations. If I was fitting data, I should have had a 1, 1, 1 column. Because that would come from the b being the same and the mx being different for that part of it. If you look back at the problem in the book, the y-intercept has always got the same coefficient, 1, 1, 1 in front of c. Yes? All right. If I give you a system of equations, your answer is the solution that comes closest to the actual answer that lives in the space of AT. That's
So it's
AT.
it's just X bar.
Huh?
X hat.
Oh yeah, it should be x hat because the solution
I was just looking.
and the geometry of this is awesome. You got this subspace and you got this vector, and if you shove this in here and you get x hat, it's the projection idea. It is the closest you can be to where you actually want to be. So if you collapse it, solve the simpler equation, you'll get the closest you could possibly get to where you want to be.
You can find the error.
Yeah, and the error is, so like, I think the book talks about least squares. Yes, they do. So least squares, it kind of like, if you square the distances between each of the components and your approximation, it reduces all of those at the same time. So you could come up with a different answer that minimizes one of those better, but then the other two get bigger. So it's trying to do that juggling act of controlling all the errors at once to make them all the best overall. Maybe. So real quick, if I'm given a system of equations, couldn't you make any, like if I'm given a system of 3 equations, woo, look at that. Couldn't I make the first 2 work perfectly? I have to be able to, yes. But then that answer, whatever that answer is that makes the first 2 work perfectly, will almost always, not almost always, more than likely will make the last one pretty bad. I can take any 2 of these and get an exact answer for those 2, which means their errors would be 0. But then the error for the last one would be so big that it would be bigger than having an answer that actually makes none of those work perfectly. Does what I just said make any sense? Okay, good. That's the whole idea. Yeah, okay. So it's let me see if I can point this out. See right here, there's the normal equation. But what we do is we actually don't do this. We actually just go straight to the potato, yes? But we are essentially solving for this and then multiplying it by A to get the projection. So the line, the line of best fit or the best fit approximation, it is the projection. I just stop early. Yeah. is hardly.
The angle between two vectors is the dot product cosine theta, right?
Do it again, sorry.
Dot product cosine theta.
What about it? What do you mean?
So that's the angle between two vectors.
Oh, the angle between two vectors
Yes.
is the inverse cosine of something.
Yes. It is.
What's the something? Cosine theta equals
Dot product.
A dot B divided by the length of each, multiply. Right, so it's like A dot B divided by the length of A times the length of E. So if you have unit vectors, that kind of kicks ass, because then it's just a dot product you need, yeah.
The way I remember that is the dot product is equal to length times length times cosine. Only people back here inverse.
Yeah, that's it. Wait, I feel like you're missing something. Yeah, A dot B equals length, length, cosine, yeah. So the dot equals length, length, cosine, yeah. Yes.
For the least squares equation, is there any way to just write something directly that says that this is like the least squares equation?
What do you mean? Oh.
Cause I know it's like on the projection vector section, like technically, it's just like with all the information we have to know for the exam, it might be easy to mix that up. So is there any way to just directly say it?
Just know it. Sorry, that was very pointy. If you just know it, then you won't have any problem. No, I mean, especially if you remember the geometry of the idea. I'm collapsing. Did you notice when we did this, especially with the ones we were doing, it always came out to be a 2x2, so it sort of like has one less dimension than I started with? And that's the whole idea of collapsing it into a space and solving a simpler problem. Actually, I keep saying simpler, but solving a problem actually has a solution. Is the right way to say that. Yes? I don't know, man. I mean, alright. Every time I've given you this kind of problem, haven't I said, find ATA, find the inverse? Haven't I kind of stepped you through it?
For the quiz you did, but not for the exam.
Oh, cool. Then no, I'm not gonna do it. Yeah. Everything that I've required you to know, you're gonna continue to need to know.
We have the sheet on Monday.
What sheet? No, I'm gonna put it right on the final. Whatever parts that you need to know, I'm gonna put it right on the final. But you can also bring chapter 4 notes. That has the Graham Schmidt process, it's got the projection process. Doesn't mean that, I understand, that does get kind of like. Yes.
Can you email out or like post the formula for chapter 4 things? I know you gave us physical copies, but.
Include it in the email you're sending me already. I can put it up on Canvas, it's just a matter of remembering. Because when I leave here, tonight, I'm gonna go home and I'm gonna grade stuff for tomorrow morning's class. So my brain is gonna switch to that mode, you know what I mean? And then I'm not gonna necessarily remember things. So that's just the way it is, yeah. So if you feel free to just remind me about stuff, it's okay. And also attempt to remind me about things that never actually happened. And I'll just swap those down. And it's kind of fun sometimes. But I'm open. If you have a suggestion, I'm open. I've had students suggest things like today. That happened today. I'm gonna put something on there based on your suggestion. No worries. Yes.
That's a really easy, like, free bonus question.
Should I?
Yeah.
Absolutely.
My definition is easy. You got it.
Our definition.
Not a problem. No, too late. All right.
Just like, what's the length of A? Something like that.
Yeah, we'd love to see more dot product and cross product on the front.
Careful what you wish for.
I won't, that's how you get a good movie.
Huh?
I'm not gonna be fearful, that's how you get a good movie.
Oh, okay, well,
There's a lot of really.
I'd rather get a good grade than an exciting moment. Amen. It looks epic. So, alright, what I hear you possibly saying is make a bonus that's accessible, that you feel like you can at least sink your teeth into, right? Hopefully I've done that. Hopefully not all of my bonuses have been like, the shit is this guy even saying? Is that true? Have they all been like that? I'm still out of touch. Oh man. Groceries. What a word. I'm sorry. Showcasing how out of touch I am. But yeah, I do strive to do that, believe it or not. I do strive to have a bonus that I feel like people, if you had time, you can do it. I'm not saying I make bonuses that I know you can't do. I'm just saying that sometimes bonuses are just, it's gotta click, or you gotta see something, or you have to have done certain kind of problems to kind of see which way it's going. But yes, I promise you I'll try to make at least one bonus problem that is accessible to all. I should have a shirt that says, reminder, I have brought nothing. So like guys can look in the perspective. I'm like, I got nothing. I am in react mode right now. Yes?
Can you do the hokey pokey?
Turn myself around. Is that what it's all about? Oh man. Sorry. It just brings me, I always hated it. I always used to be kind of put my left hand in, put my left hand out. This is getting me ready for working in the future.
Move the barrel, move the barrel.
Yes, is it, do we have a normal class time for the final? Or the
Yes.
little extended?
So there's no finals week, it's just,
Just normal
we're
days?
taking the final on the last 2 days of class.
Yeah.
This is all the same times, all the same places, yeah.
Will there be singular evaluating functions?
Only as a bonus problem, because that was part of the extra credit. Was that chapter 7? Yes, that was part of the extra credit. So if you do the extra credit problems, you will have some bonus problems that you can try, because you will have looked at that idea, yes? Yeah.
Could you go over this question, as we used the last extra credit question?
Oh, okay. There was a typo on that. Because I think I changed, because it shouldn't be 213, it should be like, I think I wanted to be 223. But I had set that up and then I changed some of the other stuff and I forgot to change that, because there's no way to get 213. Right, because I remember your vectors you're gonna work with end up having the same thing in the first, like whatever's here is here. So if these two are not the same, you can't get it. Or something, I can't remember how it was set up yet. So, yeah, somebody came up to me actually and said, should this be different? I'm like, oh, you gotta point out that, dude, so. So I don't know if that answers you. I don't know if you tried it, and if you realize that if that's not what it's supposed to be, then it helps you, or did you just not even know how to do it?
They don't even know how to do it.
Oh. So what you want is, this would be the, B would be the elements of B would be multiples of the columns in B. That would construct this. You with me? Yeah. And since we know Q and Q, we can actually construct these. When you actually have an idea what each is these. The matrix Q. So how do you construct, so real quick, if I have orthonormal column vectors in Q, how do I actually construct Q? That's the first step. and it's that whole potato process boiled a lot down, because if they are orthogonal vectors inside that cube, and a lot of the potato stuff, if I replace A with Q, it just simplifies. Right, so that's the first thing to look up is, given that A from my process is actually Q, a whole bunch of that stuff in number 4 simplifies down, yes?
Okay.
Cool. And then you can do, like I was saying, the B would be the multiples of each column to create, yeah, the B would be the multiples of each column to create what you need. And if you change it to 1, 1, 3, it actually has an answer. Yeah. Oh, yeah.
Is there a recent update that the homeworks, like, are we doing until the end of the section 8 still?
Did you get, we doing up through 6.2?
Yeah.
6.3, 7.1, other stuff. So it's only up through 6.2 and then 8.1, 8.2.
Sure. Sounds
The other sections there at the end are extra credit.
Just for the last one, I keep getting 6 over root 6, but you only have root 6.
Oh yeah, because 6 divided by root 6 is root 6.
Oh, it is?
Yeah, real quick. What's 9 divided by 3? 3. Because 9 divided by half of 3 multiplicatively is half of 3. It's half. 9 divided by half of 9 multiplicatively is half of 9.
And it's
So 6 divided by half of 6 multiplicatively is the other half of 6. So
Can I look at it as 6 over,
square root of 6 squared. Or I'm sorry.
or
Yeah.
the square root of 3 times
Square root of 6
2?
squared divided by square root of 6 is the square root of 6, correct?
Yeah,
Okay, there you go.
okay.
Thank you.
You're welcome.
So Monday, you're gonna go home?
Is
Holiday, yeah.
so that Wednesday will be exam.
Wednesday exam, yes. So you good? I'm sorry. 4. Oh, you're at 4, yeah, you see this? Where'd you see that? Oh, yeah. 4A series are awesome, but it's not really a part of this class. No, I don't think 6.4 was even a part of our homework in the first place. Yeah. The 4A series, you could study those for a lifetime. You could apply those. It's crazy. Okay, you guys all right?
Yeah.
Okay. So should we go?
Yeah.
Oh, that'd be awesome. I'm gonna go collapse. Okay.
part of the book that we don't study in this class.
Huh?
You got like 2,
We don't
I want to show you, you got like 2.
The favorite part?
Yeah.
I think it might